Off-Gassing, a scuba podcast with host Nick Hogel. In this roundtable episode, I sit back and listen to some of the biggest pioneers in the industry speak about the future of open circuit mixed gas and rebreather diving. Is there a future for open circuit mixed gas, or is it yesterday's news? Are dual rebreathers becoming the standard for future explorations? Is it time for a new blueprint for survival? Join me with guests Richard Pyle, Brian Greene, Bill Stone, Charlie Roberson, and Simon Mitchell in this historic roundtable discussion. I hope you enjoy. So first of all, I would like to say thank you to everybody for coming on here today. I know everybody's really busy, so thank you for taking the time out today to participate in this conversation. And the reason why I wanted to get this conversation going is to open up a roundtable discussion on the future of open circuit mixed gas and rebreather diving. And I couldn't have asked for a better group to have this conversation with. So if you are unaware, I am not a rebreather diver, but as I move or progress through this sport, I feel like it's a topic that keeps coming up. So obviously this is something that piques my interest, this conversation. So we can open up. It's an open conversation. So if anybody wants to start, and then we'll just see where the conversation goes.
Ryan, why don't you start with our reasons why we'll never dive open circuit trimix again?
Yeah, okay. Yeah, Rich and I actually had this conversation this morning because I'm questioning why anybody would dive open circuit trimix when here in Hawaii, a cylinder of helium now costs $3,000.
Oh man, it's up.
Yeah. And we can't figure out if it's just the monopoly of the gas company here or if it's actually that expensive everywhere in the world now.
What does a bottle of helium cost where you guys each live?
About the same.
Really?
Yeah. Yeah.
So I was just told that the embargo on helium is over, at least on the East Coast, and there is new supply. And I just got some pricing. A bottle of UHP is about $500, and a bottle of just HP is $375. So not terrible.
Wow.
That's what we pay for oxygen here in Hawaii.
Yeah, it's $300 for an oxygen cylinder now, which doesn't make any sense because there's no embargo on oxygen. It's just in the air. But yeah. Anyway, so I mean, more to the point, the question of, I mean, there obviously are still people who dive open circuit trimix, and there may have been a justification for that at some point in the past when, you know, rebreathers had not yet established a pretty decent track record in terms of, you know, the community understanding what to do and what not to do. But I wonder, at the cost of helium these days, are people doing it still as a cost-saving measure because they can't afford a rebreather, or are they doing it because there's some inherent concern about using rebreathers instead of open circuit among trimix divers? Does anybody have any insight on that?
I'm not sure it's a cost-saving measure in isolation, Rich. I think that there's no question that that's an issue, and it's certainly an issue here. And our helium prices have been kind of what Brian quoted for quite some time now. I mean, we've been used to that as a significant constraint on open circuit trimix diving. But I think that it's largely about logistics these days too. You know, like it's so much easier to use these gases for deep diving, to carry the amount of gas you need for deep diving using a rebreather than it is for open circuit. I mean, as we progress deeper, and that's what we're all doing, you know, we're progressing to deeper wrecks, deeper caves, the need for carrying so much gas with open circuit is just becoming prohibitive. I mean, bailout strategies on rebreathers are considerably easier to formulate and manage than carrying all the gas that you're going to need for an open circuit dive. I think that's been a big part of it, driving the move away from open circuit trimix to rebreathers here.
So Simon, you raise a good point, which is that even those of us who dive rebreathers trimix still carry open circuit bailout in a lot of our situations. And obviously there's a drift in other directions. Harry Harris and others obviously are pushing the boundaries, or I should say, not pushing the boundaries, but reawakening us all to the concept of taking closed circuit bailout instead of open circuit bailout, which in my mind, is kind of one of the next frontiers on rebreather. Not that it's a frontier, because people have been doing it for a long time. Bill, you've been doing it probably the longest. But in terms of mainstreaming technical diving, it still hasn't caught on widely as a closed circuit bailout option. And I guess I was curious what you guys think in terms of, are we going to get there quickly, or are we going to get there slowly in terms of closed circuit replacing open circuit as the standard bailout for your average trimix rebreather diver?
I mean, my experience is we're actually seeing that now, and I think, there was a lot of discussion about that at RF4. We've seen that over the last year or two. You see training agencies starting to talk about offering classes for CCR bailout. You see manufacturers that are offering bailout-specific units, typically in a side mount form factor. Just to go back to, why somebody would adopt CCR, in my experience, and this was 10 or 15 years ago, so it was really before the monetary factor, my experience was exactly what Simon described. It was just the logistical issues. I was sort of pushing the boundaries of what was really safe and logistically possible on open circuit. And I realized pretty quickly that just all this extra stuff, not only was it expensive and difficult, but there was a safety issue there. It was taking too much of my attention away from what I needed to be focused on, the dive. So I really feel like, yes, CCR is obviously more complex than open circuit, but there's definitely a dividing line with depth or penetration, where you certainly have a safety factor for that unlimited gas supply.
Rich and I have always been in the situation, out in the Pacific Islands where, it's hard to move stuff around, and pre-positioning a ton of helium for an open circuit expedition, it just isn't an option. And from another perspective, the way we dive when we're on expedition, I couldn't see us logistically being able to ever fill the tanks at the end of the day if we were doing open circuit. It just wouldn't work in our expedition paradigm. Plus, it's hard. It's very hard to find helium and a lot of the time oxygen out in these islands that we go to. So, getting it down to them, we've been in situations where we've shipped down ancient Steel 72s full of helium just to get them to these random islands.
I must say my mind's drawn to that. There's a famous photo, it kind of did the rounds on technical diving websites a few years ago, of that guy with kind of surrounded by open circuit cylinders. He's got about 10 of them. I don't know how he did it, and I've used it as a joke photo in various presentations over the years. And actually, interestingly, I can't remember his name, but he contacted me. He was someone you'd heard of, and he was really unhappy with me using it as a joke, because he was kind of trying to tell me that it was a serious thing. And I was like, come on, man, you can't dive like that. I mean, imagine trying to crawl into a wreck somewhere with all that crap on you. And I think it just, that photo exemplifies exactly why we can't do what we do with open circuit. We just can't, it's... And to Rich's comment before about the closed circuit bailout, it's definitely happening. I mean, I think to some extent that's driven by the depth that the divers are going to and how much open circuit bailout they need to carry. I think closed circuit bailout may not become mainstreamed for your kind of classic 80, 90, 100 meter dives, but obviously, as you know, we use double MIGs for the very deep dives in the Pierce relatively recently, so down below 200 meters, and you really, you are struggling. It's kind of the same problem. You're struggling to carry the open circuit bailout that you need to those kind of depths. So, bailout rebreathers becomes a much more tempting option, and that's obviously the road that we've gone down for those dives. So I think it will become mainstreamed, and indeed it was for very deep dives, and it was endorsed at the RF4 in the RF4 consensus statements earlier this year.
So when I played around with it a little bit, my big concern, the little demon in the back of my mind, was how do I know that first breath on that backup loop is safe? And I know one strategy is to alternate every few minutes so that you're constantly, reality testing each loop. But with an open circuit bailout, you have pretty high confidence when you stick that thing in your mouth and draw a breath, you'll have a clean, fresh breath, as opposed to a caustic cocktail or something else. So I think, to me, that's the biggest psychological barrier. Obviously, it would save the kind of logistics that Brian and I do all the time. I mean, the depth and duration of our dive is entirely limited by logistics of open circuit bailout. And we could extend our depth if we didn't have that constraint. But there's this little guy in the back of my head going, but are you sure you're going to be able to breathe? So I don't know how those of you who've used it have experienced that.
Yeah, it's a major thing, Rich. And the thing that above everything else that's facilitated dealing with that in the Pierce work has been the like the dual BOV thing, where you can switch between loops without actually removing the mouthpiece. So that facilitates doing exactly what you were talking about, which is, switching between loops to make sure that the other one's working on a relatively regular basis. But I completely agree. That is the big concern, and the thing that, makes people most reluctant to do it is how do you achieve that? But, there are ways of doing it, and that's one of them, is to have both loops plumbed into a common mouthpiece that you can switch between very quickly.
Well, I guess for me, one of the big concerns is has that second loop flooded? And Bill, when you started doing dual loop rebreather diving with the Mark 1, you started off with waterproof canisters. And I wonder if we're going to ever be talking about the future of rebreathers, I wonder if part of that future is resurrecting the past and revisiting the idea of waterproof absorbent canisters. Do you see that, Bill?
Geez, we're all over the map here. All I can say is that, 37 years ago, we had exactly these same discussions, and that was back when Heliox was just starting to be, used in production. We used a lot of it. We had exactly the same issues you had on your islands over on South Andros Island with Rob Palmer's project out there. We were there for 2 months, and getting the helium there was the big deal. And I will say that at that time, there was an exact discussion on this whole question of, how do you make the most of your gas, and the even Bill Hamilton used to say this was the gold standard was Heliox, and anything else was poor man's Heliox. And you used to do this. The question was, how much nitrogen can you tolerate, so that you don't have to spend, on the helium. But as far as the switching goes, we tackled that problem from 1984 to 1999, and we had operational dual Mark 5s at Wakulla on that project, and they were being used for the last 3 or 4 missions. And so, to come down to some of the things that people talk about as far as logistics, we had a couple of experiments at Wakulla that perhaps some of you may not be aware of. One of which was that we had a DPV mounted rebreather with disconnectable hoses, breathing hoses, that is. And the idea was that you would use the DPV system for the primary mission, and if it looked like there was going to be a problem, either the DPV died or that rebreather died, then you switch to a back-mounted unit. But there was that same question is, when you switch to that back unit or the secondary rebreather, is it going to be good? And so we actually developed a checklist for Wakulla 2 that went down that as to, what you did and periodically how often you did it. But let me just throw something out here. You made a statement a little bit ago here. You said, with OC bailout, you have the confidence that when you grab that regulator, you've got gas. I say, not quite, my friend. What happens if during the time that those bottles were staged, one of them failed on you and you went to grab that and turn it on and it wasn't working? And there have been notorious dives. You're probably aware of them. Sheck Exley had these happen to him. Hassenmeyer had this happen to him. That's why he's crippled. Is because of an OC failure on a bailout bottle that was expected to work. So in my mind, as long as you can assure yourself that the alternate rebreather has gas, and this is going to be a discipline thing, it's the way to go. And I think Simon put his finger on it, but he didn't go quite far enough. Really, the next step is going to be full helmet diving with comms, and then your switching is internal for the dual loop system. And I think, honestly, that's where things are headed. It's going to be more like a spacesuit than a diving rig.
Rich, my experience is, I agree with what you guys have said. And one of the things I'll point out from our experience is that you certainly want to verify that secondary loop is working. You want to do that periodically. The problem is every time you do that, you're introducing a failure point, because this is when loops get flooded. When people are switching back and forth, they get confused, they're task loaded, and they forget to shut off one loop or the other, and now you've flooded your loop. So you sort of have to weigh the, you don't want to be doing it every 5 minutes, I would say. You certainly probably want to do it a couple times, maybe once when you get to depth. But I wouldn't be doing it very frequently, because we've seen this happen quite a few times.
Right. Well, anyway, what I was going to say is one of the things when I played around with building dual loop rebreathers, I'm the original Poseidon rebreather had these transparent breathing hoses, and so that at least gave me a visual, like I can see what's inside that loop I'm about to breathe now. And I was wondering what's the value in having transparent canister housings and whatnot, so you have at least some sort of visual confidence that you're not about to slurp in a whole bunch of water on that first breath. Has anyone really played around with transparent either canisters or hoses? Or I know they're not, the plastics used to make transparents are more brittle, and they're it's subject to UV, and so there's cost benefits there. But I don't know how much priority to put in having a transparent loop so that I can see what's going on inside.
Yeah, I don't know whether that was part of what Peter Reedy was doing with the Prism, but that had transparent canisters. There was a guy at the PS, actually, one of the support divers this year had a Prism, and that was one of the discussions we had, was exactly that. I'm just looking at the construction of some of the units and the benefits that the various configurations bring, such as preserving the temperature of the canister and protecting it from environmental temperatures. I'm just not sure you could do it, Rich, but it's, obviously, it would be one advantage of doing so. I just think I think you get a lot of pushback from manufacturers if you try to sell that idea as something that, like which is the more important thing. I don't know the answer to that, of course, but yeah.
Whenever Rich and I see the Prism scrubber housing, we always think it would make a great fish bucket.
Yeah, I think at one point Rich actually did an experiment where they swapped a Mark V canister underwater when you were doing deco, where we did
try to prove that was possible. But you see, this company Cis Lunar doesn't sell those canisters anymore. That's the problem, and I'm trying to track down somebody who might be able to resurrect that. I know Leon was licensed them or something, right, to rebuild them for the Meg.
He did, and I still get requests for that kind of stuff. It's just it's one of those things where the tech is available, and that kind of thing could be refired up. It's just I'm not sure that it's a niche market, and so you have to think is it survivable to do it that way. It took a lot. I mean, even back when we were manufacturing those things, they were like costing us $1,200 a canister, and that was back in 2000. So it's a question of how much are people willing to pay for a capability. But the idea of a hydrophobic canister is feasible. You can really only do it effectively in a radial canister. You can't do an axial canister.
So Brian and I have them from our Mark Vs. We actually have several of them. But Brian, why don't you explain what you were telling me the other day about how you wouldn't even switch back to it?
Well, I mean, we did run into problems with them over years of use where it, it's still waterproof, but it's also, once it gets wet, it creates like this barrier of no gas flow, and we would get this, like, we called it scrubber lockup, where like on very long dives, just from the humidity of breathing for 5 hours, at the end of the dive, you were struggling to pull gas through that membrane. I remember there was one particular dive where Rich did have a flooded loop. This is at Feist Island in Micronesia, and he was able to clear the loop, but he was still not able to breathe through that canister because it was wet on the outside, and too much moisture was blocking that permeable membrane. I mean, I would love to have a new one, but resurrecting the old one would be iffy.
So the problem we had with those Mark V canisters is, they had a pleated, they were radial canisters, and so they had this pleated hydrophobic membrane on the outer shell. That was never the problem, but on the inner core, there was another pleated membrane that had the same surface area of material, but because it was such a small diameter, the pleats were all sandwiched really close together. And what would happen, according to Richard Nordstrom, I don't know, Bill, you can corroborate this or not, is that over time, dust from the softener line would eventually sort of get on that material. And when that material got wet, that dust would clog the pores. And on the outer membrane, it never seemed to be a problem. But if you got water on the inside, which is where Brian mentioned long dives with condensation, that's how you get water in the inside core. That's what would cause it to lock up. So I always figured when you have a flood, your flood is usually on your exhale side. So it's that outer surface area that you really want to protect. And maybe I thought as a larger pore size or something else that would allow lower surface area on the inner might solve that problem. But then Brian also pointed out the other thing, we were talking about this the other day, is what a pain in the ass those things were to pack. And that adds another layer of like, well, okay, radial canisters are good, hydrophobic's good, but man, do I have to pack this thing every single time and make sure it's properly packed.
I won't argue with you there, Rich. We'll switch to cryogenic canisters soon.
How much does liquid oxygen cost in Micronesia?
Hey, I've got a question for you guys. At least Rich and Bill and Brian, I know you guys are huge advocates of the solid-state sensors and have been using them for quite a while. We've been playing with them ourselves, and I'm pretty happy from what I've seen so far. Why do you think the rest of the industry is lagging on this?
Oh, I can comment on that. Well, it depends on who you talk to, but essentially, I think there's an element of not invented here. And because I've talked to divers at DEMA and stuff who say, oh, that solid-state sensor, that's just a gimmick, right? And because essentially only one manufacturer was producing them for multiple years. And so the competitors of that one manufacturer, my understanding would say, oh, that's just hype. It's not a real technology. But if you shove all the manufacturer trade wars aside, to me, those solid-state sensors are the single most revolutionary change in my confidence in rebreathers as a life support system. Pretty much anything, at least in the last decade. I don't know, Brian, you may want to chime in too, but I just find them to be massively more reliable than galvanic sensors. I mean, for a while, it's funny, we were using the original early prototypes to the point where they designed the interface where the prototypes would no longer talk to the computers, but Brian didn't want to give up his prototype because he had years of experience of it not failing.
I trusted
on it. Exactly.
Yeah. I use that same prototype solid state. I use it on my secondary monitoring system, but I used it for 5 years. The same sensor.
I if I can jump in here a little bit. There's a bunch of you guys were at RF4. I was going to go. Unfortunately, we had a 2.5-month expedition down in Oaxaca, as we usually do in the spring, and I heard this discussion several times, and we've had a number of discussions trying to encourage collaboration for example, between Poseidon and Shearwater. And I think, as Rich put it, there is this unfortunate aspect of, trade sense of vulnerability by, giving into something that is different. But when you look at the data, I can't remember, maybe it was you, Simon, that quoted this at RF4 regarding the total number of rebreather fatalities is somewhere up over 700 now that have been tracked. Is that correct?
No, I think it was, so I think the number's correct, but it was Frauke Tillmans who gave that presentation. Yeah.
Right. And so, there's still this ethical issue in my mind that a lot of these rebreathers that are being put on the market don't have the ability to tell you what happened in the event of an accident. We went down this from day one on the Mark I. We had EEPROM chips that were logging data, and Rich is very well aware of how this whole discussion went over the course of the last 40 years. Which was that, by the time we got to the Mark VII Poseidon unit, we had 3 separate unerasable chips that were logging data that you could get to in an accident at different levels of fidelity and the things that they logged. When you look at that and combine that, with the knowledge of what is likely to happen, you find out that a hypoxic blackout is the predominant failure mode when you talk about a fatality. You can have toxes, and they are serious as all get out if you're on a deep dive, and that's, the only way you got out if you can't get into a bell or something like that. And you can have things like people not putting canisters in, and we've heard them all. But by and large, the 800-pound gorilla in the room is, do you know what your oxygen concentration is? And the problem with the chemical sensors, as we found, and probably everybody in this room knows viscerally, is that you can have a brand new sensor, put it in, and have it behave differently from what you thought, one that was spent was. And so that was the motivation, and it took almost 15 years to get that SSO2 sensor to where it is. But there's a second step involved. It's not simply say get yourself an SSO2 sensor and you'll be safe. The other part of it is that you need to validate that it's giving you good numbers. And I've seen, in a number of readouts, I have seen, for example, on a Shearwater where you can look at what your FO2 is and what the projected PO2 is, and you can then, mentally compare that to what your sensors were. Back with the Mark V, we actually had a backup display that would give you direct drive sensor data, and you could compare it and look at it. And on the flip side, there was the FO2, the projected PO2, and then the PO2 of all the sensors. And so immediately you could do your own math and flag and say, these are wrong. But a lot of people get carried away thinking that rebreathers are automatic and just trust it without having that validation part. You can still use galvanic sensors as long as you're doing the validation part. And whether you do that manually or whether you do it automatically, that's a nuance, I think. There are pros and cons to both. I tend to go with the automatic, but I'm checking every 5 minutes to see if it's actually true. And so when you get down to all these questions of, do you want rebreather bailout? As Charlie said, and Simon as well, the big deal is, do you trust that you have a non-flooded loop? Okay, that's a risk, and so you can balance all these risks out and decide, what are the procedures that you want to utilize for, trusting these switches. As Simon said, Harry and those guys are using a dual BOV. I love it that you guys have adopted all the acronyms that we invented.
We did not invent BOV. I hate BOV.
But I think that's it. I think it's there's no question at all, regardless of helium price, of what you want to do below a certain depth, and anybody who thinks that there's a place for open circuit, maybe it's an emergency thing that you have on a boat, if you have to get down and undo your anchor at 100 meters depth or something like that, where you've got a 5-minute dive or something like that. But otherwise, the stories of the risks of open circuit at depth are just beyond measure. I mean, I've lost a lot of good friends because they were doing that kind of stuff where they couldn't carry enough heliox or trimix in a bailout or a side mount system, and they went down. They ran low on their heliox mix, and they had to transfer to air on the way up. That's how Rob Parker died, and this kind of stuff goes on. So to me it's like open circuit. It was a phase of technology that was it opened the door when Cousteau introduced it to the world, and then there was another barrier when they found out that you couldn't go beyond a certain depth because of the nitrogen problem, and then we found out that we could switch to helium. And by the way, we weren't the first to use helium. There was the whole stuff with Bond and crew back in the 30s with the Navy was investigating all that for commercial diving, and then there were groups in South Africa using it in the 60s. So it just kind of came, and got reinvented along the way. But the bottom line is, and everybody here, I'm sure, has been at 100 meters plus and had an open circuit tank, and you're watching the gauge, the dial go down visibly with every breath. Not over a couple of minutes, but every single breath. You watch that gauge ping down and back up. That's scary as hell, and that's one of the reasons why when we were at the first Wakulla project, we were trying to figure out ways to gang tanks together because we didn't want to have to do these regulator switches. So we had sleds with 4 composite tanks on them, or sometimes 3, and then we tried to gang that together. There's a sketch that Terry Skiles did for the Wakulla book that had this guy on a DPV, and there's this gigantic string of tanks being towed behind him, for open circuit, and that was the reality of 1987. But that's not today. And I can't remember if this came out, Rich, but I think you guys were talking about a working group to look at the issue of how to make dual rebreather systems effective, and what standards ought to be in place for training.
Well, I think the time has come for something like that. And I know each of you has experience with it, but it seems like, in the early days of technical diving, there were these little epicenters around the world where everyone was reinventing the same wheels, right? I was out in Hawaii, and there was the Florida crew and the England crew and Australia crew. And when, Mike Manduna came along and sort of gave us Aquacore and a forum to talk to each other, suddenly the pace of advancement accelerated, because we could not only learn from our own mistakes, we could learn from everybody else's mistakes. And it feels like, even though like Olivier Isler and others have been using multiple loop rebreathers for a very, very long time, they haven't been on the cusp of mainstream. But I think now they're on the cusp of mainstream, and maybe it's time, to find out who has experience using multi-loop dives, and some of them use it for extra duration, some of them use it because it's the only practical way to go that deep. Some of them use it because they can't get enough helium wherever they're going. I mean, there's different reasons for having it. And it seems like those who have been exploring it ought to get together and start sharing experiences and writing them down, and sort of write a Shekeli style blueprint for survival, but with, multi-loop rebreathers.
That's actually a really good idea, Rich. It would make a great kind of next step workshop. Maybe the next rebreather forum, or maybe we don't want to wait that long.
10 years? I don't know if I want to wait.
That's right. Yeah. Maybe some, like an OzTech workshop, or a Eurotech, or Tech Dive USA, like one. So there'll be a forum where it can be done. And I actually think, if like just knocking these subjects around between this group, which is a pretty expert group, it's emerging that the use of dual rebreathers is probably mainstreaming. That is probably the next big step forward, and I think that would be a very good topic for a workshop somewhere.
I agree.
Yeah, Bill, we had talked to a few people at RF4 about this idea, including Harry Harris. Just based on the number of like side mount rebreathers I saw at RF4, every time I saw one of those, I was thinking, hey, could I use that as bailout? So I think that is the direction that things are going to go.
Yeah. Yeah, well, of course you could. Of course you could. And that's exactly how they're marketing them. You can use it as a bailout rebreather. And we're already there. Like wet mules, that's our MO now. That's it, for these deep dives. That's how we're doing it. It's kind of a no-brainer. It's how we get it over the hump into the sort of wider community. That's the thing. And I think Rich's idea of a workshop at a suitable forum in the near future would be terrific.
Yeah.
Yeah, I would underscore workshop, not forum, because we've had, panels and things like that at places like OzTech, and, you get a few sound bites, but it really doesn't advance the technicality of it. I tend to live in a couple of different worlds. You guys tend to be focused on diving, but I do a lot of different types of expeditionary work. Are any of you guys familiar with Petzl?
Mm-hmm.
Yes.
The mountaineering.
Sure.
They started off actually being cavers, and if you ever have a chance to look at one of their catalogs, it's really quite curious. They have a bunch of very inventive people, or a group rather, in their engineering team, and so they're constantly coming up with crazy ass gadgets for you to try to use on rope and things like that for all possible purposes. But the really interesting thing is that they have an entire section, not just one page, but more like about 20, of how you can utilize these things. And to me, that's something that's completely missing in diving right now. What you have is a couple of leaders that move forward, and so, it's interesting to me to see this path that we've followed. When we started thinking about, when I started thinking about rebreathers in 1984, after a discussion with John Zimmerich, at a place, I guess you've been there, Charlie. You've been to the Peña Colorado, right?
I have.
You have, yeah. Right. See, so that conversation took place right there at base camp in that canyon, and John said, you don't need to go open circuit. Here's how you do it, and from that point forward, the recognition was that open circuit was not really where things had to go. It had to be a redundant rebreather if you were going to actually have true redundancy, because that was just the logic at the time. I studied a lot of stuff, including the NASA spacesuit, Bliss and a few other things, and looked at their architectures, and their architectures were single point failures. And so this whole idea moved forward, at least on my point of view, was, okay, how do we make a dual rebreather work? And then what happened is there was a funny change, and it got to the point where it was no longer experimental, and we had to do something with it, which turned out to be this 1994 San Agustin expedition. And immediately what happened was people said, I feel comfortable managing one rig. Why don't we do this thing where we have bailout bottles, okay? And you could either do a butt mount bailout bottle or you do side mounts with open circuit, and then have the rebreather. And that way, you kind of get the best of both worlds. When you were doing production stuff, you would use the rebreather, and if you had a bailout, you had a string of bottles. We actually had a string of bottles through the San Agustin sump. A lot of people don't know that, but they were there, they were placed, and so you could use them if you had to bail out, and then everybody was diving side mounts and the back-mounted rebreather, and that went all the way through, Wakulla 2 until the end, when the whole thing came back again, and everybody said, we're getting too far. This is the bailout string is not going to work, and so we were being pushed by the nature of the problem, just as Harry and Craig are, down there at the Pierce, and Charlie and guys, it's so you're back, to realizing that closed circuit bailout is what you need, and that's independent of closed circuit decompression. But I would throw another thing in here on the basis of this whole analog to the Petzl catalog, is that there are other places you can put rebreathers, and we started to crack that door open at Wakulla, which is having DPVs carry your rebreather for you as a bailout. You say, that's crazy. Well, go and experiment. The idea of being able to have disconnectable breathing hoses that went into that with the counter lungs on your chest and shoulders, that worked. We tried it out, and it was one of these things where it was an experiment, and everybody gradually migrated towards the dual rebreathers on your back approach, which is what Craig and Harry are using right now. And so to me, it's like how you rig this up is what your mission determines. And so, do you want a DPV carried system? Maybe if you're going a long distance and you don't want the drag on your back, you let your vehicle do the drag characteristics. And then, how do you, to me, there was another one that Charlie was talking about, switching and going back to a rebreather. It's the bigger one to me is if you leave a rebreather hanging, on a shot line, or if you have it at a stage depot on your way back to your habitat or whatever, in a place like Weeki Wachee. What happens when you turn that mouthpiece? Is there a way to ensure that thing hasn't flooded while you've been out there for the last 8 hours doing saturation work at 100 meters depth? Those are kind of the things. Plus, what are the management procedures, and if you do have a dual rebreather, should you be talking? Should the computers be talking between those? And if you don't have computers talking between you, how are you going to manage that manually? Are you going to have a bunch of tables and transfer your tissue tensions? Anyways, I'll shut up for a bit here and listen.
Hey, Bill, what if I had an autonomous underwater vehicle that had a rebreather built into it that followed me around?
Yeah, I believe that's called Copus.
Yeah.
Rich can explain.
I mean, you're right, Bill, that these ideas of rebreathers being used in different applications, we're using habitat rebreathers now. I know they are as well in the Pierce Resurgence. I would never go back to open circuit in a habitat. There's just no reason for it. So we have a habitat scrubber, makes our life so much nicer. But that's not unlike what you're talking about, is disconnecting the rebreather from the back or the normal usage and utilizing it in different ways. So I think all these ways that we're starting to utilize, whether it be habitats or side mount, are going to start pushing the envelope and changing the way we think about the use of the technology.
Going back to the idea of a workshop, would it be feasible to give people practical advice on all of these options and what the nuances are and what the trade-offs are? Rich hit on a note back there saying, what we need is a blueprint for survival for rebreathers. Simon knows this for for sure, and Rich does. We were back at whatever it was, RF3, I guess, down at Duke University or whatever. And there was somebody who had given a talk about fatalities relating to cave diving, not open circuit, or not rebreathers, but open circuit cave diving. And they had a timeline of the rate of fatalities per year and by year, by annual. And so, it started off like in 1965 or something like that and went up. And the date at the peak of the curve was when Blueprint for Survival was published. And beyond that point, there was an exponential drop-off in fatalities in cave dives, just because of that. It was traced right to it. There was no question about it that was the dividing mark. Yes, there was implementation, through training agencies and things like that were all getting fired up at that time too. But nobody had ever codified it in a way that could be usable, and that's really what that little tiny blue book did. So maybe it is time for something like that for rebreathers and all of their manifestations, and I think, it was simpler back in the old days where, guys like Exley and Clark Pitcairn and John Zimrick and Paul DeLoach would go down and they'd drag tanks in and stage them in the caves, to where they'd have 2, 3, 4 sets of stage bottles in the cave, and then they'd do their big dive, and then they come out looking like that, that picture of the guy surrounded by a tank farm of dead tanks, and you come out like that. But the thing was, that was the only method that anybody knew about back in those days. They just got very good at what they had, right? Today, we've got a lot of options, right? You've got side mount rebreathers, you've got back mount rebreathers, we've got potentially vehicle mounted rebreathers, potentially AUV carried rebreathers. This is not science fiction, it's actually happening. It's underway. So the big question to me would be, how do you get across to people who have an objective? I want to do this. What are your options for that? And then laying out what the deal is, what the steps are, what the risks are, what you have to pay attention for. If I'd have had something like that, I would have used it.
Simon, you're the most experienced among us for organizing workshops. What would it involve? Do we have to get a sponsor or, pick a venue? What are the mechanics of getting a group of people together like that?
I think you call Michael Menduno, right? That's the first step.
Yes, you need some enthusiasm, among a leadership group. But I actually don't think it would be that difficult if we tacked it onto an extant conference of some sort, because one of the things you fear when you organize something like that is that you might not get the sort of, a quorum of people, or you won't have the momentum required to, get a suitable audience. But if you tack it onto something that's almost guaranteed to succeed, like an Oztech or a Tech Dive USA, I think it would work pretty well. And then you just need, I don't think you need a lot of money. Usually they pay for themselves with attendees paying a fee to go along, and you need a good faculty. But I don't think for a subject like that, I don't think we'd have any difficulty. I think there'd be lots of leaders in the field who'd be quite happy to come along and share their experience. And the other thing you do need, though, and this is where I've found myself cast in this role a number of times, is you need someone who's prepared to essentially grip it up and write it up in a coherent kind of way, and like overall lead the process of producing the workshop findings. And as you saw, you were a very strong participant in the RF4 consensus statement session, which is hard work. Those things are, you've got 50 or 100 of the biggest egos in the diving world packed into one room, and everyone wants to have their say, and it's not always smooth sailing. But if you've got strong leadership in that regard, usually you can nut out some useful consensus statements, and I don't think it would be that difficult. Look, depending on when the next one comes around, I would be happy to maybe talk to you about it, Rich. What you want is people, strong leaders who people respect and who they'll respond to it, a request for talks and participation. But I think we could do it. I think it would be well worth it. I'm just trying to think. The next Oztech will probably be next year. That could be a target, or something else. In a similar time frame. You need to start at least a year out. It can't be done at the last minute. Anyway, I could rave on for ages about how to organise a workshop, but I think it's doable. But I would strongly recommend tacking it on to something that's already going to happen, rather than trying to organise it as a de novo event. I think one of the tech shows would be perfect.
So one of the most effective workshops I've ever been, actually there were several of them in a totally different field, database, informatics, biodiversity stuff. The way they structured it was they sort of pre-organized it with the group of people who were the obvious, the most vocal and experienced in the realm. Before there was any talk of an actual physical workshop with attendees, they got together and communicated regularly via email. It was before Zoom, but you could do it with Zoom. And they actually generated, Simon, the manuscripts ahead of time. And rather than, because you can never get them to write the manuscripts afterwards, right? That's just whoever suckered into being the coordinator of, the cat herder always ends up getting screwed on that. But the idea was to generate the written materials in advance and hammer them out and review them among this sort of smaller circle of peers. And then when there's kind of this sort of emergent consensus and you've already gotten most of the proceedings written, that's when you plan a sort of broader, with attendees, workshop, and you have the presenters present what has already been vetted through each other and refined through each other. And that way you kind of hit the ground running already once you put it out there. And it's not that you create the final form behind closed doors in the ivory tower, but you at least get a head start on the outlines of what the conversations are, what the weaknesses are, what the main contentious points that people disagree on. And that way when you open it up to a broader audience, you have a little more focus on the areas that needed attention rather than all the egos just arguing with each other about, everything. I don't know. That's just one approach to take.
Yeah, I mean, I've been doing scientific workshops for a long, long time, and the danger that you get is that they just turn into gab fests, and then somebody like Simon or myself ends up spending a year or two trying to decipher what the heck was said, and putting it down and getting it into print. To me, it would be. I like what Rich has said here. The rub is trying to figure out what constitutes the forward progress that you really want out of this thing, and having that goal clearly labeled before you even go in, so that if it turns out that somebody missed something, which I doubt if you had this crew right here involved with that, plus maybe another 5 or 10. You could quickly iterate on what the issues are, and then to me the trick, what is the purpose of this proposed workshop, and to me it's to do the same effect that Exley's book had on the safety of diving, right? We've got this high performance, Lamborghini here that has been invented, and those who are fortunate enough to have the cash to own one and the places to use them have been doing extraordinary things, for the past 30 years. And there's still the issue that these are Lamborghinis, and if you get somebody behind the wheel and they say, wow, I've got a Lamborghini, I'm going to push my pedal down all the way to the floor and see what happens. Well, if you're not a trained driver, the problem with curves and ice and trees come to play, and then you have another statistic. And so to me, the number one goal coming out of this would be, number one, how do we instruct people in a manner that is entertaining? And this is why I go back to this Petzl catalog, because this is what they do, right? You look in there and they say, here's a scenario, here's how you might solve it, and then they go to the next page, here's another scenario, right? And so to me, a series of chapters, if you will, that say, if this is what you're trying to do with diving, here's how you might do it safely, and here's what the risks are, lay them out, and here's what you got to pay attention to explicitly. And then at least somebody coming into this new, and even some of the rest of us here, you might want to reread that before you go, you do your next, big push or whatever. Because let's face it, there's still this world of open circuit diving. It's how people basically learn, and from there to 30 or 40 meters depth, it's how most of the world is still going to go underwater. And so what we're talking about here is a handbook for the elite, the people who were the equivalent of the cave divers of the early 1980s, who were the ones who were doing things that open circuit, open water divers were never even thinking about back in those days. And now here you've got this tool and people are doing unusual things with it. And so, and we do have this track record, and it's very similar. We're still on the curve up, when I want to use that analogy to Exley's, curve of cave diving fatalities, we're still on the curve up. We haven't reached the peak. So the question is, how do we turn the peak? And maybe...
If I can jump in there for a second, I think you bring up a really good point, and it's the danger of cheerleading the technology too much and pushing it out to people, and I applaud, Rich and Brian, your hesitancy to just strap on a bailout rebreather and say, go for it, because there is a cost, and it... there is a real cost. There's a lot of baggage that goes along with that, and unless you do it incrementally, it's a lot. You've got 2 loops to monitor. You've got 2 sources of oxygen. You've got 2 of everything now, and there can be a lot of task loading involved. And I think one thing we see with accident analysis is rarely do the machines break or kill people. It's the people make mistakes, usually because of some form of task loading, and use the equipment improperly or get themselves into trouble because they don't understand the way to use the equipment. So I think we need to approach this cautiously and not be too much of cheerleaders for the technology, and have an honest assessment of how it can be used.
It reminds me, back in the early days, like in the late 80s, a friend of Brian's and I, a guy who used to, probably still does, do aquarium fish collecting, named Tony Nahaki. I was talking to him. I had just gotten into trimix and was, learning how to do all the decompression and everything. And Tony had routinely, for the previous 3 decades, been doing air dives to 300 feet to go look for rare fish that he would catch. And I was explaining to him all the advantages of helium and no narcosis and, accelerated decompression with oxygen. And he said, wow, that all sounds very impressive. But, I think I'm just going to stick with the devil I know. And at that moment, I was thinking, how foolish of you to keep air diving when you have this better alternative. But then the flip side was how foolish of me to tell this guy who has 30 years of experience knowing what to do and what not to do in his paradigm, to push him in a new technological direction that is outside his, area of comfort. And there's no correct approach. There's truth in both of those. And so there was a long period of afraid of stick with the devil I know, when air divers didn't want to switch to trimix. And then there was a similar transition of open circuit trimix divers and whether they want to go to rebreathers. And, maybe there's some of that going on with galvanic oxygen sensors versus solid state sensors. But I certainly think we're at that point now when it comes to closed circuit bailout versus open circuit bailout. There's plenty of people out there who have lots of years of experience and know what the strengths and weaknesses are of their open circuit bailout paradigms, and they're babes in the woods when it comes to what are the costs and benefits of a closed circuit bailout. And, maybe there's a there and maybe it's not, but we need to sort of find that out. And then eventually, like all those other transitions, it'll be forums like this saying, why would anyone ever dive open circuit trimix again? When there was a time when there was a rational reason, which is lots of experience and didn't want to try to learn a new technology when it may or may not be ready, or they may or may not be ready. But that's the transition I want to see us overcome with dual rebreathers. Either we decide that, yeah, they're a neat niche solution to a very niche problem, or no, there's a general answer here. We just need to aggregate all of the wisdom and experience of people who use them to find all the gotchas and design something that actually works in a broader spectrum of scenarios.
Yeah, and something to add to that, Rich. From our very small deep diving fish scientist niche world, we're not necessarily trying to push further. Maybe down to 200 meters if we could, but I see it as more, could having closed circuit bailout or a dual loop rebreather make us more flexible or more efficient? I think that's the thing. It's
or even more safe.
We're not really, yeah, and make it more safe. We're not really trying to push any further. Like, there's no deeper cave for us. It's for us, it's kind of diminishing returns the deeper we go for fish diversity anyway. So
it's also really cold down there if you're just wearing a shirt.
And it's really cold, yeah. So.
Rich, there are these things called wetsuits, and they even have dry suits.
Don't get me started. That's not the purpose of this discussion.
Yeah, I would like to go back on one point that Charlie said there, and that I don't think the goal here is to popularize the use of rebreathers. I think it's to provide a series of options that would allow it to be used safely in environments. And part of that, I think, is elaborating what constitutes a feasible environment to work in with the technology as we know it so far today. That we're coming on, only about whatever it is, 8 months after Craig and Harry's effort there with hydrogen. And so, there is this question, in everybody's mind who has been paying attention to this, is that, okay, we have a data point of 1 right now, and some anecdotal evidence from a chamber dive, conducted 35 years ago by Comex. And so does that change our game? Brian very cautiously threw out a number of 200 meters, and the reason that was there is because what we found out is through accidental data is that once you go beyond 200 meters, shit starts to happen, and it's only a question of, are you physiologically selected to survive that? Was your procedure better than somebody else's? We know that there's a problem when you go beyond 200 meters. The rebreathers and helium opened the door from 40 meters to 200 meters. Is there an enabling agent to go further, and if so, how much further is realistic? You have these data points. They've done a 600 meter dive, or was it an 800 meter hydrogen dive, Simon? I think it was 800, right?
705 meters was the deepest chamber dive that Comex did. That was Mavrostomus. Yeah.
Right. So you have a data point there. You have a single point, and you have Harry and Craig's single data point. And so we're kind of at the age back when There were a few rogues, in the 70s and very early 80s who did do like a single helium related dive, and then there were in some of those cases fatalities, and everybody said, oh geez, this is too dangerous, we shouldn't be going here, and then it all kind of went into a hiatus for 5, 6, 7 years, and then it came back, with a vengeance, and now it's here permanently. And so, we're not. I'm not going out here and advocating hydrogen diving to anybody. It's just one of these things where we're seeing maybe what the next card turned over is here, and where that might go. So, to me, if you did do a workshop like this, the idea would be, what can we come up with regards to procedures that will make rebreather diving safer, and then what are some actualized methods and types of equipment that you can use, and what are their limitations and gains, and so you basically build a how-to book, if you will, for people who are going to do this anyways, and maybe help them survive. I don't think the idea is to popularize it. I think the idea is for those of us who are explorers and who do have a reason for going beyond 40 meters deep to say, okay, this is really useful. I'm going to read this document because there's a lot of collected wisdom in here on how to come out alive and not crippled. That was my take on it. Not so much to say, hey, everybody should become a dual rebreather diver, and let's all go out and follow Rich down to 200 meters and chase fish, or follow Charlie into Weeki Wachee. No, I don't think that's the case at all. Everybody knows that the people on this meeting right here are at the cutting edge, and everybody's going to make their own decisions to do that, and they're doing it internally. It's just that there are other people who might try this and not have the benefit of that wisdom, and end up one of those statistics. I'd just like to see the curve turned back into that exponential drop that Blueprint for Survival had on cave diving, and I think that's feasible.
So, Bill, one of my favorite all-time quotes, as Bill and Brian at least know, is from Bill Stone himself, which is, the difference between adventure and exploration is data. And you had mentioned data points, and it occurred to me that Scheck wrote Blueprint for Survival on a foundation of actual body recoveries and actual accidents and statistically, measurable, this is why you need 3 lights, and this is why, all those sort of things. And obviously we have a data pool on rebreather fatalities that we could start with to build those sort of survival modes. I remember at one point years ago, Kevin Gurr and Jill Heinrich and I were talking about sort of coming up with a rebreather equivalent of a Blueprint for Survival, and it kind of ended up being, the ideas we bounced around were kind of like, well, this is what our experience tells us is a good idea, but it wasn't based on actual accident analysis. Like here's what actually gets people into trouble. We have that for closed-circuit rebreathers. I don't know that we have that for dual or multi-loop rebreather dives yet. I know of at least one person who's died in the context of a multi-loop rebreather, but what we do have is near misses. So I think we're still kind of at that early stage of where the people who have tried it have had close calls, and a lot of the wisdom that emerges is more from the close calls than rather any kind of a statistical analysis of actual failure points. But you have to start somewhere, and having at least that anecdote, what I call robust anecdote, is better than nothing. Controlled data is better than robust anecdote. We saw the same thing in water recompression and other issues that were controversial for a long time. But I'm not sure if I have a point here. But I guess your point about data points, I think, needs to lie at the center of whatever conclusions emerge from some sort of consensus statement. It needs to be driven by real world experience, if not fatalities, at least real world close calls, rather than just sounds like a good idea. Because there's lots of sounds like a good idea in technical diving that turns out not to be such a good idea, but it gets ingrained in standard. I'm sure Brian knows what I'm talking about in particular contexts. But that's the thing you don't want to do, is a lot of arm waving and a lot of, here's what I think the right thing to do is, without having that based on a foundation of actual incidents and actual experience.
There is a certain amount of data available on single RB accidents,
right,
that should be analyzed, and the wisdom from that related. But I think you're dead on, is that there's not enough people using dual RBs or RBs and RB bailouts. Charlie, let me just put you on the spot. If I said, Charlie, we're gonna throw out some ideas for a workshop, and we'd like everybody to tell us a story about how they nearly didn't come home. Do you have one?
Sure.
Would you be open enough to relate it?
Yeah, sure. Yeah, not me personally, but certainly within the team. And, I sort of already related that a little bit, and this is sort of the danger between switching back and forth between loops. And this is one of the biggest concerns that I've seen. Even very experienced divers can get task loaded and fumble that.
You got any anecdotes from the Piers, Simon?
So open disclosure, it's been on the tip of my tongue to mention this, as various among you have mentioned exactly this kind of thing. But one of our decompression protocol for the hydrogen dive involved, I think Charlie mentioned it, the use of Triton rebreathers hanging inside the deepest habitat. And when they got to that habitat, one of them was flooded. And that caused us a lot of difficulty. And it was just lucky that because the gas inside those deep habitats is just air, so that's why the Triton rebreathers are there, for breathing in appropriate decompression gas. And there's no scrubbers in those deep habitats, so can't breathe it for very long. And it's just lucky we had a very well choreographed series of visitations and buzzer comms in those deep habitats. We were able to send messages and get a sense that something was wrong, go down, figure out what it was, and then actually we had a period of several hours of quite, frenzied is probably too overstating it, but moderately busy time mixing gas on the fly, so that it was Craig's Triton that was flooded, and we had to supply him with open circuit gas to get ourselves out of that situation. And actually, he was going through it a lot faster than we thought he would. And it was an issue because I was the surface supervisor, and I was blowing out all my support divers going down and up, supplying him with gas. It just shows you exactly what you've all been talking about. You have these redundant rebreathers. Well, they're not really redundant in this setting. Like, we're planning to use them, but a rebreather that's been sitting there waiting to be used, and then you find it's unusable, and it created quite a few issues. And I'm telling you all this, it's going to come out in the documentary because it's actually the big selling point for the documentary maker, that I've got all this footage of us running around looking pretty panicked on the surface, trying to mix all this gas really quickly and get it down to Craig so that he didn't suffocate or, end up breathing air that had rising levels of CO2. And it was a bit of an issue. So, right there is an anecdote from the Pierce that illustrates a number of the points that we've been talking about, like redundant like rebreathers that have been sitting waiting to be used, then not being usable. It certainly affected our hydro. I mean, it all worked out, but I'm just glad we had the logistics in place that we did.
Can I ask a question on that, Simon?
Yeah.
Was that Triton unit breathed down to the hab, or was it just carried down?
No, it was carried down. It was breathed in the habitat, though, when it was installed. It was carried down and then breathed when it was installed, but then left. And it was actually left overnight. So it had been in there for probably 24 hours before it was discovered that it was unserviceable.
So how could it flood? I'm curious.
Because it was hanging in the air, and then when they got down there, it had slipped down into the water. So just a classic mistake, Yeah. Yeah, but I mean, it was all still sealed up, but I don't actually know that we figured out exactly how it flooded, but it did. Yeah.
There was actually a death in Florida. A guy took his rebreather off, went through a restriction, continued to explore on open circuit. This was at the Devil's Eye about a decade ago. Came back to his rebreather, it was flooded, did not have the redundant open circuit gas to get out. So there's certainly data points that regarding that.
That was Berman, right?
Sorry?
That was Steve Berman, right?
No, this was a guy named Mark Fivey who did some of the. This was after Berman died. He was doing some of the exploration in the new section of Devil's Eye, beyond the rock on rock restriction, and that's where he had left the unit.
Well, this is one of the reasons why I harken back to the waterproof canister, because if flooding is one of the fundamental ways you lose your loop, a waterproof canister makes that just a minor little inconvenience. I have firsthand experience with that. That's the other side of firsthand experience, and I kind of feel naked these days diving with a non-waterproof canister, knowing that how vulnerable it is to a complete loss of loop. I mean, there are only so many ways you can completely lose a breathing loop, even especially if you're falling back to just pure survival mode. But one of those is you flooded the sorb, and from personal experience, you can flood a loop and recover the loop as long as your sorb stays dry. So I don't know. For all the reasons why we may not want to revisit waterproof canisters, there may be some reasons why. If not a canister, I'd always try to envision not the canister being waterproof, but an insert in the breathing loop, essentially having a hydrophobic membrane that a standard canister sits within. So you don't, so the membrane stays with the rebreather, not with the canister, so you get the easy packing and so on. I still think there's value in trying to explore that as a solution if you're going to rely on a rebreather, not as a triply redundant bailout, but as a absolutely needed to survive piece of equipment.
Well, that's a good point, Rich. And most of the back-mounted rebreathers have sort of solved this issue to some extent just in water tolerance. Most back-mounted units have pretty good water tolerance. You can take on water, and it's either not going to reach the scrubber, or even if it does, it's not going to come back to the diver. The advent of side mount units now has completely turned that upside down. Side mount units are notoriously bad water tolerance, and that's just the nature of the design, really.
Mm-hmm. That statement you just made is the kind of thing I would like to see emerge from this workshop. So, that there's an empirical difference between flooding potential for a side mount versus a back mount, and basically because a back mount holds a consistent and predictable orientation with respect to gravity, whereas a side mount may not. I don't know if that's the reason or not, but or if it's just simply you need to take a back mount design and put it on a side mount. But that's an interesting thing that you just brought up there, Charlie. I didn't.
Or you just have a greater probability of bumping the mouthpiece, in a side mount unit, anything of that nature, But that gets down to little things. It's like a lot of stuff has you remember the old Mark V gas control block, Rich, right? I don't know, Brian, maybe you've seen it too.
Brian, yeah.
But there was a feature on there that allowed, there was a feature on there that allowed you to go on open circuit oxygen during decompression. And so you could actually plug a K bottle into that rig. But we knew that was a dangerous thing, and you had to be really cognizant that that's what you were doing. And so we put in a two-step lock on the gas control panel. So you had to consciously remember that you had to throw the one switch and then rotate the other switch, and you couldn't do one without the other as a precursor. And so you had to at least have some level of, being there. Before you did that, it was enough to make you think. Because if you just randomly said, I need oxygen, I'm going to turn that valve, it wouldn't work. You had to say, oh, right, okay, I am using oxygen. I need to be sure that I'm, above 6 meters or whatever these days. This is something we don't have right now on current, for lack of a better term, we'll use the common term BOV, of having an inability to open that unless, you know that you've got it in your mouth, for example. Or like Simon was talking, with the dual system. By the way, I've got a patent on that from 1990, Simon. That exact concept.
That's fascinating. I can't remember who made those. It was one of the well-known manufacturers who made those for Harry and Craig. I don't know who it was. Perhaps I shouldn't name them, even if I can remember. Anyway, they were made by.
I'm sure Bill could sue for dozens of pennies for all the profits that's been made off of selling them.
Well, that's right, exactly. Yeah, N of two. So Nick, I don't know if you had any other areas that you wanted, like we've kind of been rambling around a bit here, and but like incredibly productively, and I personally, this is heaven for me, sitting talking to guys like this about, chewing the fat about rebreathers. However, I have a limited amount of time. I will need to go within 30 minutes at the latest. So I just wanted to know if you had any other areas that you wanted covered before I have to go.
No, this has been absolutely wonderful. Yeah, and on that note, we could definitely just kind of call it. No, this has been just great. I didn't think there would be an end to this conversation. That's why I just kind of put it out there as an open discussion. So unless anybody else has anything to add, yeah, we could end it on that note.
The only thing I would say is this is a conversation we need to resurrect, Rich, and well, all of us. I mean, we'd be a good core group and maybe a few others to think about a workshop on. I actually like the idea of a slightly broader, like a new, revised blueprint for survival, but with an emphasis on the emerging trends and technologies in rebreather diving, like, side mount, like, dual rebreathers for bailout, those kind of things. It's time. The time has come. I think it's right. I think you're absolutely right. Bill, you kind of said that. And so I'd be very keen to revisit that at some point. And I'm not sure I would take an overall leadership role in the whole thing, but, it's something we could talk about. But maybe when the next clearly high-level technical conference gets mooted, we could talk about doing it there.
Well, we got you on the line here, Simon, just for fun. What do you think the absolute depth limit would be for exploration with all the tech that we know and the possibilities that we've been opening up here in the last year?
Well, so I think the Pierce is a good microcosm to look at that question, in terms of the Pierce. So we'd gotten to 245 meters in 2020, and at that point, you're breathing probably something like 5% oxygen, 95% helium, 5% nitrogen, and you're butting up again, and it's still going deeper, right? So the way forward is down. And so there's two problems that arise simultaneously, and they have mutually exclusive solutions. So one is HPNS, which Harry gets quite badly. So he's flapping around, quite a bit at 245 meters. But the other one is gas density. And the way to fix the HPNS is either to go down more slowly, which you can't, not in technical diving, or add a more narcotic gas. So if you add more nitrogen, you make the gas density problem worse. So you can't fix one problem without making the other one worse. So the answer is a light gas that's also slightly narcotic, and that's why hydrogen, right? So that's why the whole hydrogen thing came into it. Now, having done that and not blowing ourselves up and, not causing any problems that, not obvious, the way forward might be clear now. Like, that dive might, in the fullness of time, be seen as the path down from 250 meters in a kind of relatively, I was going to say safe, but it's not really safe, but in a pragmatically doable way. But then you start saying, well, what's the next problem that's going to come up? And, so we've fixed the HPNS problem, we've fixed the density problem with hydrogen. So now we can progress down below 250. What's the next problem going to be? And the next problem is probably going to be decompression logistics. The decompression time is just exponentially soaring, and things like thermal protection in the Pierce.
Well, the temperatures there certainly aren't helping you.
Yeah, exactly. Temperatures and all that kind of stuff. So it'll start, the issue will start to become, well, how do you do all the decompression you need from those kind of dives? And and I'm not saying for 100% sure we've fixed the HPNS and density issues, but it would seem that the path now looks clear down to maybe 300 meters notionally. But man, you're going to have a lot of deco if you start going to those depths on exploration kind of dives. And you'd have to be very motivated to want to do that. So I guess, I don't know. I mean, you could say, well, maybe 300 meters is where we see ourselves going now with hydrogen. Beyond that, hard to say. But I think decompression time is going to start to dominate the picture.
Do you recall what the saturation decompression time is for 300 meters?
It's a long time. It'd be a week. If you truly saturated, it's really long.
Yeah, that's where I'm getting at. Okay, and these are the kind of things that I'll give you an analog here. And before I leave that thing, I'm gonna mention one thing. Simon was there at a little roundtable meeting that we had at OzTech last fall, and Harry was there, and Craig, and JP Mbera was there, and he was going over all these COMEX tables. And it was one of the best moments I think I've had in a diving scenario. And JP goes, well, the problem is that if you get beyond 3% hydrogen, we can't be sure that you won't have an explosion. And Harry goes, well, we just dived 5% last weekend in my pool. And the look on his face, on JP's face, was just, I wish I had a camera rolling. It was awesome. But no, I'll give you one other short aside here. We've been spending, good God, I don't know, 37 years for me now working this place called Cueva Cheve in southern Mexico. And for the longest time, a 10-day or a 2-week stay underground was about what would be merited for what you were doing there. And then suddenly there was a breakthrough in 2021. And what nobody was prepared for, but what ended up happening is if you went in that cave to go work at the bottom, you were spending a month in the cave. I spent 29 days down there, and we'd had a couple days work at the end there. The point I'm getting at is that people adapt to these environments, and you say, all right, how do we go about doing this? When we were at Wakulla in 1999, I don't know how many people here are aware of this, probably Rich is, almost all of the latter dives that we were doing were saturation dives. And so from that point, the decompression profiles for everybody, regardless of whether they spent 2, 3, 4, 5, or 6 hours at 100 meters depth, didn't change, and so we were reaping the benefits of having crossed that Rubicon, if you will. And so, Simon, you said a week, to which I would say, okay, let's do it.
Well, it would certainly be days. I'd have to look it up. In fact, we're about to publish a paper in DHM that's got all the sort of accelerated decompressions from sort of slightly emergency decompressions from SAT. So it'd be quite interesting to go and have another look at that. I edited it ages ago, so I can't quite remember, but that'll be coming out in the next issue. They'll be very long. But you're right, Bill. I mean, people find a way. It's just SAT dive decompressions are done in SAT systems, and they're a damn sight more comfortable than a habitat in a cave.
I've heard that KUR has movies.
We do. The director's cut of Das Boot will take up a lot of your time.
We have other things to worry about, like sharks and currents and stuff like that.
Oh, for you guys in the Pierce, I mean, the deco issue, that's a solvable issue. Bill did a lot of work on that in Wakulla. I mean, they had a pretty luxurious habitat for the time. I mean, even for now, it would be probably one of the nicest ones that was ever built. The fact that it could move up through the water column, and you were completely out of the water. You could eat, you could drink, you could do whatever. You could tolerate a pretty long decompression if you can get comfortable.
Oh, yeah. No, I get it. It's just all logistics. I mean, it's not easy to put a big habitat in the Pierce. The Wakulla's a little bit different. You got a bit more open space, but.
And staying warm. I mean, that's going to be the key for you guys is staying warm. That probably matters more than anything else as far as you know, decompression world.
We'll
Yeah.
schedule the next workshop for when liquid rebreathers are on the forefront, and we solve the decompression problem entirely. But now it's all about pneumonia.
All right. Well, look, we better. I better cut this anyway, guys. Look, and like I say, heaven for me. We could talk all day and quite happily go round and round, but not sure that will serve Nick's purpose.
Well, Nick, I think you've served your purpose here. You got a consensus on a workshop to write the next blueprint for survival. I'd say you can remember this date.
This has been absolutely amazing, and thank you very much for everybody taking the time to participate. So yeah, I thank you very much.
Thank you, Nick, for organizing.
Right.
Thank you.
Thank you.
Yep, thanks a lot.
Enjoyed it.
All right. Yep, good to see all you guys again.
Yeah, you too.
Offgassing, a scuba podcast.